circumference and area of circles. So the circumference of a circle is the distance around the outside. So the circumference is the distance around the edge of a circle. The other parts of a circle that we need to know are the diameter, which is the distance or the length from one side of the circle to the other going through the center, and the radius, which is the line from the center to the outside. And obviously, since the diameter goes from the center to the two edges straight through, the diameter is 2 times the radius. Now we've been introduced to the concept of pi. Pi is this little Greek letter, and it is an irrational number, 3.1415925. It goes on forever. It does not form an endlessly repeating pattern, so it's not a recurring decimal. You can't write it as a fraction, and it is absolutely central to the area and circumference of a circle. And you will have noticed from the exercise we did in class that any circle, if you measure its circumference and divide by the diameter, you get around about 3. And in fact, if you could measure it absolutely exactly and do circumference divided by diameter, you would get pi. Now, what that means is that the formula for the circumference of a circle is pi times the diameter, or since the diameter is 2 times the radius, the circumference is 2 times pi times the radius. So when we're finding the circumference of a circle, it depends. So here's our 2 formulas for circumference. It depends on whether we're given the radius or the diameter. Now you can, if you want, always use the radius, because in this case the radius would be 7.5, or you can choose to use the diameter formula for circumference. So circumference is 2 times pi times the radius, although of course you don't need the times signs there. 2 times pi times 10, now you do need the times. And you use your calculator. Pi is here on your calculator. 2 times pi times 10. Now, often the green calculators will give you this answer, 20 times pi. Use the little arrow key to get our answer and round to, let's go 1 decimal place. Because we're in meters, our answer is meters, because we're just measuring the distance around the outside, its length. Circumference of this shape, we've got the diameter, so we might as well use pi times the diameter. Pi times 15, circumference, pi times 15, what a surprise, 15 lots of pi, hit the arrow key, 47.1 centimeters. So that's circumference of a circle. The area formula has to use the radius. So if you've given the diameter, you'll have to divide it by 2 to get the radius, and it is pi times the radius squared. So this is our area formula for a circle. So for this one, area is pi r squared, pi times 10 squared. Now that's pi times 100, so I'm sure you can work out that that's 314.2. But you could always get your calculator out if you wanted. We're in meters, so it's meters squared. Area for this one is pi r squared, and we don't have the radius, we've got the diameter. So over here you do radius is diameter divided by 2, 15 divided by 2, the radius is 7.5 centimeters. You don't have to do this, but it's a really good idea to show exactly what you're doing. So pi times 7.5 squared, grab your calculator, use the squared button, 176.7, and we're in centimeters squared. So that's circumference and area of circles. Two different circumference formulae, only one area formula. You must use the radius. The radius squared is not the same as 2 times the radius. Now you will sometimes get really interesting shapes like semicircles, or this one here, which is a sector, part of a circle. Now with a semicircle, or even a quarter of a circle, area would be easy. It would be just find the area of the whole circle and divide by 2. Find the area of the whole circle and divide by 4. But perimeter of a shape always needs the straight bit as well. So yes, you'd find a quarter of the perimeter to get this bit around here, but you'd add on 2 lots of the radius. You'd find a half of the perimeter of the circumference to get this bit around here, but you'd add on 2 lots of the radius. Now this is when it's a quarter of a circle, and this is when it's a half of a circle. But there's actually a formula that works for circumference or area of any fraction of a circle. And it is perimeter is 2 times the radius, because I need the 2 straight sides, plus the fraction of the circumference that we've got. And the fraction that we've got, now here it's a half and here it's a quarter, but here it's 30 out of the total of 360. So we use the symbol theta, meaning the angle, out of 360, and I've got that fraction of the circumference, which is 2 times pi times the radius. So this will get 2 times the radius, the 2 straight bits, plus the fraction of the circumference that we want. And for area, I don't need to worry about the radius because I'm just looking at the space inside. So I need that fraction, the angle over 360, I forgot my degrees sign, times the area formula, pi r squared. So this, now if this was for a semicircle, then it's 180 over 360, or a half. If it's for a quarter, it's 90 over 360, or 1/4. So this will let us find the perimeter and area of a sector, part of a circle, where the radii go into the middle, and it takes out this little segment shape, sector shape. So this is 2 times 4, the radius, plus 30 over 360 times 2 times pi times 4, the radius. So that will be 8 plus, and then all this can go in together. You can use your fraction key, 30 over 360, or you could have simplified that if you wanted, times 2 times pi times 4. Use your little fraction key. Don't forget to pop in our 8, so that's plus 2.09. So that's 10.09 centimeters perimeter. Sorry, I'm making a very crowded page here. For area, 30 degrees over 360 degrees times pi times 4 squared. And you can enter that all in at once. Use your fraction key if you want, 30 over 360 times pi times, now you can do 4 squared in your head if you want and get 16, or you could have done 4 squared there, wouldn't matter. Use your arrow key again, 4.19, and we're in centimeters squared. So anytime you're dealing with the perimeter and area of shapes involving circles, look at how much of the circle you've got, and remember you can use a fraction.